Here's the diagnostic test solutions. Okay, work through them pretty quickly, but hopefully enough detail for you to know what's going on. Alright, integrating definite integration. Okay, there's a topic, definite integration, where we're going to integrate, so we put square brackets around it, increase the power by 1 and divide by whatever that new power is. Okay, between 0 and 3. So remember the rule, integral of ax to the power n dx is ax to the power n plus 1 on n plus 1 plus c. Since it's definite integration, we don't need the plus c because it'll get cancelled out anyway. From here, substitute in x equals 3 and x equals 0. So 3 to the power 4 on 4 minus 0 to the power 4 on 4. Okay, and then just calculate it from here. 3 to the power 4, we should know from memory, 81 on 4. Okay, that'll do. Try and just keep it in fractional form. Part B, try and do integration. There's a fraction, so I'll first investigate whether the top is the derivative of the bottom. So if I was to differentiate the bottom, I'd get 3x minus 1, reduce the power by 1, multiply by the power, and multiply by the derivative of what's inside. Okay, there's no way that I'm going to be able to change the 5 to turn into this big mess here, 18x minus 6. There's no way I'm going to be able to make it look like that. Okay, so it's not one of the problems where we have the derivative on top of a function equals natural log of that function. Okay, not one of them, which a lot of people will probably try to do. Okay, instead, I'm going to change this so that I have it in a form that I recognize by bringing the denominator up to the top with a negative power, and then I can apply my general integration rule. So integrating, 5 comes along for the ride. This thing with the power in chain rule, I'm going to increase the power by 1 and divide by what that new power is. Okay, and I also need to divide by the derivative of what's inside the brackets. So also dividing by 3. Between 1 and 5. And from here, it'll just be a substitution. Before I substitute in, I'd probably make this look a little bit neater. So this is really positive 5 divided by negative 3. So negative 5 on 3. And the 3x minus 1 with the negative power, we can bring down the bottom with a positive power between 1 and 5. Substitute. Alright, so for the disruption, okay, sub in 5 here. And sub in, so minus 5, 3 times 1 minus 1. Okay, subbing in those two values. Okay, I end up getting 5 on 7. You can put it as a fraction if you want. These next 3 it says to do exactly. So integrating the exponential function. Okay, remember the exponential function is the one that when you integrate it, you get that same function. Okay, when you differentiate it, you get the same function. So I'll sub in x equals 2 minus x equals minus 1. And it said leave it as exact form, so leaving it like that's fine. If you really want, you can make sure it has a positive index as well. Okay, last 2. Okay, integrating sine, so I know that when I differentiate sine, I get cos. When I differentiate cos, I get negative sine. So if I'm trying to integrate from sine to cos, I've got that negative sign there. So I know that the integral of sine is going to be negative cosine of x between pi on 2 and pi. Should be able to do this with exact values. Okay, 0, pi on 2, pi. Okay, cosine is the x-coordinate, so the coordinates of this point. 1, 0, coordinates of this point correction, that's 0, 1. This point is minus 1, 0. So when I sub these points in, minus cosine of pi minus cosine of pi on 2. Okay, so minus cosine of pi is the x-coordinate here, so minus 1, minus 0. Okay, cosine of these angles are just the x-coordinates of the point on the unit circle. Okay, positive 1, exact value. Final problem. Okay, another trig type 1. Trying to do integration here. This thing here is just a number. Okay, if I had the integral of 3 dx, it would be 3x. So the integral of this number is just e to the pi on 2 x. Okay, plus cosine. How do I get cosine? By differentiating sine. So plus sine x, okay, between 0 and pi. Okay, substitute in pi and 0, so e to the pi on 2 times pi plus sine pi minus e to the pi on 2 times 0 plus sine of 0. Okay, I've got two angles I'm after, 0 and pi. Coordinates of these 2 points on the unit circle, minus 1, 0 and 1, 0. We know that sine is the y coordinate, so when I go through this problem, sine of pi, y coordinate of 0, minus e to the pi on 2 times 0 is 0, plus sine of 0, y coordinate 0, end up with just pi times e to the pi on 2. And that's exact value. If you've just somehow gone from here to a decimal value, you'll get 0 points. Okay, moving on. So these ones are dealing with speed, displacement, and time. So if we just remind ourselves of the rules for displacement, velocity, acceleration. That must be... Okay, remember this diagram. Okay, if I have displacement, I want velocity, or I have velocity and want acceleration, I'm differentiating. If I need to go the other way, I'm integrating. Okay, so keep that in mind. I'm given a function for the displacement. Car is traveling along the highway. Okay, zoom, zoom. Part A, write the function for the velocity of the car. So the velocity is the derivative of the displacement. So I'll differentiate this, 4 plus 10t. That's my velocity function. Easy, done. Part B, write the function for the acceleration of the car. I know that the acceleration is the derivative of the velocity. Differentiate the velocity function, 10. Okay, the acceleration is always 10 in this scenario, okay, regardless of what the time is. Okay, you could draw the 3 graphs, see what it looks like. As a guess, something like that for S and T, something like that for V and T, something like that for A and T. Okay, remember, differentiate quadratic, you get linear, differentiate linear, you get a horizontal line. Understandings that you should have had from last year. Okay, final one to do with displacement. A rocket is traveling at 15 meters per second squared. Alright, so let's write down some of these things that we know. There's a lot of data here. So the acceleration is 15. A rocket is traveling at this speed after 4 seconds. So the velocity after 4 seconds is 83. Okay, so I need to find, those are the things that I know. Since I know I'm dealing with functions now, I'm going to make this a of t. What do I need to find? I need to find b of t and I also need to find v of 10. Okay, find the function for velocity, v of t, and how fast it'll be after 10 seconds. Okay, let's do this. I've got acceleration, need velocity. Velocity is the integral of the acceleration with respect to time. So I'm integrating 15 dt, 15 t plus c. Okay, the c value, I'm not sure what it is. Okay, I'm going to sub in t equals 4 and v equals 4. Okay, essentially this bit of information that I know. Okay, so I know that 83 equals 15 times 4. I use the time sign. Plus c. Okay, so c will equal 83 minus 60. C equals 13. So my velocity function, v of t, is 15t plus 13. Okay, also need to find v10. So write that, find what v10 is. I need to substitute that in. Okay, 163 meters per second. And write some sentence about that. Calculate the total displacement in the first 12 seconds. Okay, I'll do it down here. Okay, part B. Find displacement for the first 12 seconds. Okay, remember, if I've got a velocity time graph that looks something like this, the displacement for the first 12 seconds will be the area under here. Okay, so displacement, and this isn't the displacement function, this is just the displacement that we're calculating. It will be the integration of 0 to 12 of 15t, and I don't need to write the plus c, correction, plus 13. Okay, here's my velocity function. Phew, almost made a mistake. Okay, this is dt. So I'll integrate away. It's 15t squared on 2 plus 13t. Okay, between 0 and 12. And I'll substitute in 12 and then subtract 0 substituted in. Okay, you should be able to do this pretty routine by now. Okay, we know this whole part with will be zeros over there. Just a case of substituting all these in. Okay, 1, 2, 3, 6 meters will be the displacement, and I'll write some story about that as well. Okay, correction, I made a little error here in the subtraction. I, for some reason, wrote 13 there, so it should be 23 all the way down. Okay, all of these should be 23s. Okay, so this should be 173. Okay, and that means all of these should be 23s as well. So I'll rub out all of these. All these 13s should be 23s. Okay, and my displacement shouldn't be what it was, should be 15. One, 3, 5, 6, that's better. And the units are meters. Okay, oops. Even with that little error, still would have got an A for the question. Okay, just a little calculation error. Okay, looking at some of these more interesting problems. Okay, question 4. Calculate the area between the function f of x equals x cubed. Okay. That's what x cubed looks like. Between that function, the line x equals 0.5. So here, x equals 0.5. Here, x equals 0.5. Here, x equals 0.5. This vertical line is all of the points where x equals 0.5. We do the same thing at 1.2. And the x-axis. Already got an x-axis. So it's asking me to find this shaded area. The area will be the integral from 0.5 to 1.2 of x cubed with respect to x. Okay, so do our integration. Substitute in 4, substitute in 1.2, and then substitute in 0.5. Okay, let's see what we get. Okay, 0.503. Okay, and since it's area, it needs some units. Since there's no units there, it's just units squared. If you wanted to do a check on your graphics calculator, okay, just type the integral in. Hopefully we're okay doing that. Options. I want to do some calculus, I want to do an integration. Make my calculator look like yours probably does. I want to do integration of x cubed from 0.5 to 1.2. Okay, 0.502. So that's a good way to check that your answer is right. Okay, justify your solution. That's one of the criteria. Okay, question 5 is a differential equation. Okay, so if you had trouble with this, look at your notes on differential equations. The atmospheric pressure P at a point h meters above sea level. Alright, so I've got the Earth here. Everything where imagine we're standing on Earth level all over the place. It changes with the height at a rate proportional to t. So I've got some height here where I'm here in my aeroplane. Okay, and I'm wondering what the pressure is going to be. The idea is that it changes. Okay, define my variables. Let P be atmospheric pressure. And let H be height above sea level. Okay, what it's telling me is that this rate of change, the rate at which the atmospheric pressure changes as we go higher or further away from sea level in our aeroplane, is proportional to, so is some multiple of P. Okay, and I know from differential equations that this tells me that P equals some initial pressure, okay, times e to the power kh. Okay, normally e to the power kt, but I've got h on the bottom. Okay, so from here my task is that I need to find, so what else do I know? Before I see what I need to find, I know that at h equals 5600, the pressure is half of the initial pressure that it was on sea level. Okay, so when I'm at sea level here, I've got P naught. Okay, when I am 5,600 meters above sea level, the pressure is half. Okay, so half of P0, P0 on 2, or 0.5 P0, whichever ones you want. I'm going to choose 0.5 P0. Okay, if you don't know what P0 is and you're not comfortable with it, you can just say assume P0 is 5 or some number. Okay, I'll show you why it doesn't matter. Okay, so I know at that height the P equals P0. Okay, and I need to find H. I need to find the height when the pressure equals 0.25 P0. So how we got this? I can't just sub in P equals 0.25 pH because P0 because I'd have unknown K and H. So I'm first going to try and find K to complete my equation as best I can. Finding K, I'll sub in H equals 5,600, P equals 0.5 P0, and see if I can find K, okay, into this equation. So my pressure is 0.5 for the original pressure. My original pressure is still my original pressure, and e to the power K times 5,600. Divide both sides by P0. Okay, it will essentially cancel those two out. So 0.5 equals e to the power 5,600 K. Convert to a log statement. So this unknown power is the power I need to raise e to, so the natural log, to get 0.5. I should have a k in there as well. The power was 5,600k. So k is natural log of 0.5 on 5,600. Okay, and I can get a decimal approximation for that if I want. Calculator's playing up. This is entertaining TV, I'm sure. Yeah, it's a really small number. I'll probably just leave that as the... Okay, yeah, we'll do it with a decimal approximation. If you want to be Superman, do it just with the fraction. Alright, so my function, okay, my model is P equals the initial temperature, e to the power, correction, there's a negative there, negative 0.000124 should be enough for us. H. Need to find the H when P equals, remember this is the thing I'm trying to find, always write down what you need to do. Find the H when P equals a quarter of P, so I'll sub those in. Okay, so I'll sub in P equals quarter P naught, and solve for H. So 0.25 P naught equals P naught e to the power, this massive power, times H. Okay, again, cancel the P naughts, divide both sides by P naught. Trying to find that unknown power. This unknown power, by converting into logs, is the power I need to raise e to in order to get 0.5. Okay, and then it's just a calculator exercise to find the height. I get something like 11179.79. as my height, meters. Okay, is this reasonable? Sure. Answer, reasonable as greater than 5,000. Okay, and pressure decreases, okay, with additional height. With height. Width is a bad word. As height increases. Okay, so I didn't need to know anything about why pressure decreases when height increases. Okay, I don't need to know like the physics of it. We're just setting up a model using the information in the question. Okay, and using our data to try and find one. So when I said doesn't matter if you don't know what P0 is, you can just choose a value. I could have chose like P0 equals 1,000 because they're just going to get cancelled out in all of our calculations. The 1,000 would be dividing by 1,000 here instead of dividing by P0. A final question. Okay, is the volume of this pig trough. Okay, the farmer reckons that, or wants it to have a volume of 0.8 meters cubed and says the depth must be 20 centimeters. Okay, is he correct? Okay, assuming that this is a parabolic cross-section. So the way I would go about this is probably to flip the thing over. Alright, first of all, remember volume is area of base times height. Okay, so to be able to calculate the volume, I know what the height is, I need to find the area of the base. Because it's not a semicircle, it's a parabolic cross-section, I'm going to need to find what the formula for the parabola is, and then use that to find the area. Okay, by finding area under the graph. I'm going to flip it over so that my parabolic cross-section starts at the origin, has a maximum point at 25 and 10, okay, to test whether this guy's right or not, and has a point of 50, 0 as well. Okay, this point at the end is 50. Okay, so my first task is to find equation of the parabola. Okay, my points are 0, 0, 25, 10, and 50, 0. My general equation, y equals ax squared plus bx plus c. I'm going to sub those three in. Alternatively, you could put these 3 points into your stat mode and do a regression, parabolic regression, and you get the equation that you're after. But I'm going to sub the points in for funsies. So 0, 0 will give me 0 equals c. Okay, 25, 10 will give me a times, so 625a plus 25b plus c equals 0. And my final equation would give me 2500a plus 50b plus c equals 0. Okay, so 3 equations, 3 unknowns, but first equation is pretty straightforward. I'll sub 1 into 2 and 3. So 625a plus 25b equals 0. Okay, new equation 2. And the other one, 2500a plus 50b equals 0. Okay, now I've just got 2 equations and 2 unknowns. Need to solve simultaneously. I'm going to be lazy and use my graphics calculator, which is okay to do because I'm in modeling problem solving land. Simultaneous equation, 2 unknowns. Put in my coefficients. Okay, solve away. I get 0, 0. What have I done? Yeah, I made an error somewhere. This should be 25. Okay, the y value is 25. Correction, the y value is 10. Hopefully I get something nice. Yeah, as always, something really nice. So A equals 0.016 and B equals 0.8. Okay, so the function I have is, was it negative? Yeah. Minus 0.016 x squared plus 0.8x. So to find the area, I need to integrate it from 0 to 50. Okay, with respect to x. I get an area of, where is it? 333. I'll put that in. A squared. So the volume is the area of the base times the height. 333.3 meters squared times the height of this sort of cylinder section. And I'm going to get 733.26 centimeters cubed. Okay, and we're saying that it's supposed to be 0.8 meters cubed. Correction, so make sure all your units are in line as well. Okay, this is centimeters squared. Okay, and I'm trying to convert units here. So I should just put them all into meters squared and meters. So to convert this to meters squared, this 333.33, need to divide it by 100 twice. Okay, so it's 0.0333 meters squared. Put in my meters squared here, and times it by however many meters it is. And I get 0.07 meters cubed. He's saying it's supposed to be 0.8. Okay, I think I'm out by a factor of 10 somewhere. Not sure where it is, but just showing the process of how to go about it. Either way, I'd say that from here I'd say volume not 0.8 meters cubed. Okay, and he would need to make it deeper to increase volume. Okay, as in this bottom part needs to go down, okay, to make the parabola have a bigger area, so the volume would be bigger. Okay, good luck.